Welcome to Get Your FRQ On. This question is from the 2009 B exam. It's question 4 and it is not calculator active. In the question stem, we have a couple of functions defined and we are provided with their graph. And there is a region bounded between the two functions. And in part A of this question, we are asked to find the area of that region. So we're given in the graph, we can tell pretty easily that the two curves intersect when x is equal to 0 and x is equal to 4. This is important because this provides us with our bounds of integration. And either by analyzing the graph or just understanding what the graphs of these functions look like on your own, it should be obvious that the graph of the square root of x is greater than or equal to the graph of x over 2 for all x between 0 and 4. So the square root of x is going to be the function that's on the top. So the area of this region would be given by the integral from 0 to 4 of square root x minus x over 2 dx. Note that this is not a calculator active question. So in order to find this area, we have to find the antiderivatives ourselves. So the antiderivative of the square root of x, which is equal to x to the 1/2, is going to be 2/3 x to the 3/2, and then minus 1/4 of x squared, and we need to evaluate this between 4 and 0. And notice that both terms evaluate to 0 when we use 0. So we really just need to worry about the 4 here, and when we evaluate this integral at 4, we get 4/3 as the area of region R. In part B of this question, we are told that cross-sections being taken perpendicular to the x-axis are squares, and to find the volume of the resulting solid. Since the cross-sections are being taken perpendicular to the x-axis, we're going to integrate with respect to x. However, in order to find the volume, we need a function that gives us the area of any cross-section, which is just going to be the difference of the two functions. Since the square root of x is the graph that's on top, we would subtract the lower one, x over 2. That gives us the side of one of these squares, and then the formula for the area of a square is you just take the side and you square it. So our integral would just be the integral from 0 to 4 of the square root of x minus x over 2, quantity squared, dx. Again, not a calculator active question, so we are going to have to expand this and find an antiderivative for it ourselves. Square root of x minus x over 2 squared is going to be x minus x times x square root of x plus x squared over 4. And if we do antiderivatives for that, we can use the power rule on the middle term, because x times the square root of x is just x to the 3/2. Creating our antiderivative here and finding it, evaluating it between 4 and 0. Again, notice that everything evaluates to 0 when x is 0. So we really only have to worry about the 4. And when we plug in 4, we get a couple of different terms. You can try to simplify that if you want to. You don't have to. If you ended up with 8 minus 64/5 plus 64/12, that would actually be okay. You would not be required to simplify that. In part C of this question, we are asked to write the integral for the volume when r is rotated around the horizontal line y equals 2. Notice we don't have to find the volume, we only have to write the integral. All right, now since we're rotating around a horizontal line, and both curves are below this horizontal line, we're going to integrate with respect to x, and we have to come up with our two radius functions. So our big radius is going to be the axis of revolution, 2, minus the function that is furthest away from this axis, which happens to be x over 2. And our little radius function, little r of x, is going to be 2 minus the function that's closest to our axis of revolution, which is the square root of x. So these two functions, big R of x and little r of x, give us the two radii that we need. And this is going to be a washer method problem. So the integral for this volume is going to be pi times the integral from 0 to 4 of our big R function squared minus our little r function squared. So pi times the integral from 0 to 4 of 2 minus x over 2 squared minus 2 minus square root of x squared dx. And since we don't have to evaluate this, We only need to write it down in a correct form, and we should be okay.